Okay, example 8, we're going to introduce a slightly new rule. So you could still only go right or down, but you could also go kind of downish right. So you could go down these diagonals. So let's see how this is going to pan out. So there's only one way to get there, one way to get there, nothing has changed on that one. Two ways to get here. Now this one is going to be the first interesting one. So there's one way from there, one way from there, and two ways from there. And all three of those ways feed into that point, so that's going to give us a total of 4. So now we can go, that's 5, that's 6, 3, 7, 4 from there, 3 from there. That's 4, 5, 6. This would be 11. 7 from there, 4 from there. And this would be 12. And this one would be 18. Okay, so we've built it up to the next interesting ones. Oh, not quite. This one would be 12 and 11 would be 23. So we have 18 from there, 12 from there, and 23 from there. And that's going to be a total of 30 plus 23, 53. Now this one's even more interesting. So we have 11 from there, 5 from there, 4 from there, and 4 from there in a slightly different direction. And all 4 of those things all feed into this one point over here. So that's going to be 11 plus 5 is 16, 20, and that's going to give us 24. And then we're done. Like, there's nothing really exciting left to go. Now it's just clean up. 47, 77, 100, and 177. So 177 ways to get from there to there. The new rule on this one is that you can finish on either B. So let's see where that goes. So 2, 3, 4, 5, 3, 6, 4, 10, 10, 15, 20, 35. If there's 15 there, then there's only going to be 15 ways to get there. 35 there is 35 ways to get there. And we could finish in either or. We could finish in both of them. And so how would we do that? We would add those guys up. I probably should not use that color. And we're going to get a total of 50 different ways. So 50 different paths to start at A and end on any of the B's. Our last example here. This is just showing it a slightly different one. Imagine this is a checkerboard, and so we can move diagonally up. So we're going to move diagonal up. And I want to know how many ways to get to the top. So this thing, there's essentially one way for it to go there, one way for it to go there. One way for it to go there, and these two guys could go over there, 2 ways. 2 ways to get there, 3 ways to get there, 1 way to get there. And as a total, 2 plus 3 plus 1 would be a total of 6 ways to the top. And that's path counting.